In this lesson, we're going to learn more about empirical formulae, molecular formulae, and percentage composition of compounds. You know these inorganic compounds: hydrogen sulfate, hydrogen sulfite, and hydrogen sulfide. You are also familiar with their molecular formulae. Molecular formula indicates the actual whole number ratio between the elements in a compound. In hydrogen sulfate, the actual ratio of hydrogen to sulfur to oxygen is 2 hydrogen atoms to 1 sulfur atom to 4 oxygen atoms. For the other two compounds, these are the actual ratios. In the same way, we get the following organic compounds: ethene, propene, butene. And these are the molecular formulae of these compounds, indicating the actual ratio of the elements to each other. This ratio between the elements can be simplified. The simplest ratio of the elements to each other in ethene is 1 carbon to 2 hydrogen. In propene, it is also 1 carbon to 2 hydrogen. And for butene, also 1 carbon to 2 hydrogen. The simplest ratio of carbon to hydrogen for all these compounds is 1 to 2. This simplest whole number ratio between the elements in a compound is known as the empirical formula. With inorganic compounds, the molecular and empirical formulae are the same. With organic compounds, the empirical formula is not always the correct molecular formula. Look closely. The molecular formulae are multiples of the empirical formula. For ethene, the empirical formula is multiplied with 2. For propene, with 3. And butene, with 4. In organic chemistry, compounds can have the same empirical formula and have different molecular formulae. CH2 is the empirical formula for many different organic compounds that will be discussed in detail in grade 12. The question now is, how is the empirical formula determined? In other words, the simplest whole number ratio between the elements in a compound. The answer is in the mole ratio of the elements to each other in the compound. You must calculate the number of mole of each substance. If the mass of each element in the compound is known, this equation can be used to calculate the number of mole of each element, because mass in gram is known, and the molar mass can be obtained from the periodic table. If the percentage composition of the compound is known, it means that 100 grams of the compound consists of the percentage of each element in gram. Now the mass of each element is known, and the number of mole can be calculated with this equation. Remember, the mole ratios are always whole numbers. Now divide all the mole quantities by the smallest number of mole, ensuring that the mole ratio are whole numbers. These whole number mole ratios are then written as a subscript next to each element in the empirical formula. To determine the molecular formula, in other words, the actual whole number ratio between the elements in a compound, we must know with what factor the empirical formula must be multiplied to give you the molecular formula. This factor is determined as the ratio of the molar mass of the molecular formula to the molar mass of the empirical formula. If the ratio is 1, The molecular and empirical formulae is the same. If the ratio is Y, then the molecular formula will be Y times more for each atom in the empirical formula. Let us now apply this knowledge. Determine the empirical formula of a compound that consists of 2,04 gram hydrogen, 32,65 gram sulfur, and 65,31 gram oxygen. Empirical formula means the simplest mole ratio of the elements to each other. Start by writing down the elements that the compound consists of. Then write down the information that pertains to each element. There are 2,04 gram hydrogen, 32,65 gram sulfur, and 65,31 gram oxygen. To determine the number of mole, you must get the atomic masses from the periodic table. Hydrogen 1, sulfur 32, and oxygen 16. The number of mole of each element is calculated with this equation. Now substitute the values into the equations and calculate the number of mole hydrogen, number of mole sulfur, and number of mole oxygen. To get the simplest whole number mole ratios, the number of mole of each element is divided by the smallest mole number, in this case by the 1,02 mole of sulfur. The mole ratio therefore is 2 to 1 to 4. The empirical formula therefore contains 2 hydrogen atoms, 1 sulfur atom, and 4 oxygen atoms. Determine the empirical formula of an iron oxide compound if 8 gram of the compound consists of 2,4 gram oxygen. You now know that when the empirical formula is asked, you must determine the simplest mole ratio of the elements to each other. Iron oxide contains the elements iron and oxygen. The mass of the iron oxide compound is 8 gram, and this 8 gram contains 2,4 gram oxygen. The mass of the iron can be determined because the law of conservation of mass applies. The mass of iron in this compound is 5,6 gram. Even if it is an easy calculation, it must be shown. Add it to the other information. But now you know that you must look up the atomic masses on the periodic table. With the masses and the atomic masses known, this equation is used to calculate the number of mole iron and the number of mole oxygen present. Substitute the values and calculate the number of mole iron and the number of mole oxygen in the compound. To get the whole number mole ratio, the smallest mole number is divided into the number of mole of each element. This ratio must be whole numbers. Multiply both the numbers of mole with 2. The whole number ratio is 2 to 3. In the empirical formula, there are 2 iron for 3 oxygen atoms. Do you still remember the stock notation to indicate the name of a compound that contains a transition element? The valency of iron in this compound is +3. The name of the compound is iron 3 oxide. Determine the empirical formula of the compound with the following percentage composition: 24,45% copper, 12,82% sulfur, 25,65% oxygen, 36.07% water. Ensure that you know what is being asked. Empirical formula. For that you need the simplest mole ratio. The elements present is copper, sulfur and oxygen, as well as the compound water. Because the percentages of the elements are given, it means that 100 gram of the compound contains 24.45 gram copper, 12.82 gram sulfur, 25.65 gram oxygen, and 36.07 gram water. This equation is used to calculate the number of mole after the atomic masses of copper, sulfur, and oxygen are obtained from the periodic table, and the molecular mass of water is calculated. Remember to show the steps. The equation to calculate the number of mole must now be written specifically for each element. Also for water. All substitutions must be shown before completing the calculations. Copper, sulfur, oxygen, and water. To get the whole number mole ratio, the smallest mole number must be divided into the number of mole of each element, as well as into the number of mole water. The mole ratio of copper to sulfur to oxygen is 1 to 1 to 4. And these numbers are written as subscripts next to the symbol of each element. Because water is a compound of which the formula is H2O, the number of mole water in the compound is indicated with a 5 before the formula of water. The molecular formula is also CuSO4 5H2O. The molar mass of a compound is 30 gram per mole. Determine the molecular formula of this compound if the percentage composition is 80% carbon and 20% hydrogen. Ensure that you understand the problem. The molecular formula indicates the actual ratio between the elements in a compound and is a multiple of the empirical formula. This multiple is obtained by dividing the molecular mass with the empirical mass. Now you can write down your information. We don't have the name of the compound, but we know that it consists of carbon and hydrogen. The molecular mass of the compound is given. The percentage composition can be expressed in gram. 100 gram of the compound contains 80 gram carbon and 20 gram hydrogen. The atomic masses of carbon and hydrogen are taken from the periodic table. To calculate the empirical mass, the empirical formula must be known. The empirical formula is determined by getting the simplest mole ratio between carbon and hydrogen. You know this equation to calculate the number of mole with. Remember footnotes so that you can substitute the correct values. Calculate the number of mole carbon and the number of mole hydrogen. To get the whole number mole ratio between these elements, the numbers of mole are divided by the smallest mole number. The empirical formula is 1 carbon atom and 3 hydrogen atoms. Now calculate the mass of this empirical formula. Substitute it into this equation to determine the factor. The molecular formula is greater than the empirical formula by a factor of 2. The number of atoms in the empirical formula must therefore be multiplied by 2. C2H6 is the correct molecular formula because it gives the actual ratio between the elements in the compound. C2H6 is known as ethane. The molar mass of a compound is 88 gram per mole. Determine the molecular formula of this compound that consists of 6 gram carbon, 1 gram hydrogen, and 4 gram oxygen. The molecular formula indicates the actual ratio between the elements in a compound and is a multiple of the empirical formula. This multiple is determined by dividing the molecular mass with the empirical mass. We do not have the name of the compound, but we know that it consists of carbon, hydrogen, and oxygen. The molecular mass of the compound is given. Also the mass of carbon, hydrogen, and oxygen. Get the atomic masses of carbon, hydrogen, and oxygen from the periodic table. Now you can calculate the actual number of mole of each element. Check the footnotes. There are 0.5 mole of carbon, 1 mole of hydrogen, and 0.25 mole of oxygen. The whole number mole ratio must be obtained. Do you remember how? Divide by the smallest mole number. For each 2 mole of carbon, there are 4 mole of hydrogen and 1 mole of oxygen. The empirical formula is C2H4O. And the mass of this empirical formula is 44 gram per mole. With both the molecular mass and the empirical mass now known, the ratio between the molecular mass and the empirical mass can be calculated. The molecular formula is bigger than the empirical formula by a factor of 2. Therefore, C4H8O2, also known as acetone. Let us summarize. Molecular formula is the actual whole number ratio between the elements in a compound. The empirical formula is the simplest whole number ratio between elements in a compound. The molecular formula is a multiple of the empirical formula and is calculated with this equation. This ratio is the factor by which the atoms of the molecular formula is more than the empirical formula. Follow these steps to calculate the empirical formula. This is the end of the video, but do the test to see whether you really understand the work.